Welcome to Lesson 80 of Course 2 of Saxon Math. In this lesson we're going to talk about transformations. We're going to draw a figure and it's an image reflected along a given line. We're also going to draw a figure and its image after a translation. And we're going to draw a figure and its image after a rotation. So let's get started. Alright, so let's just start with some vocabulary first of all. Reflection means like looking in a mirror. You're going to flip a figure to produce a mirror image of it. But you got to remember you have to do the flip. So just like when you put something in the mirror, it doesn't look exactly the same when you look in the mirror. It looks just the opposite. That's reflection. Rotation just means you're going to turn it, just like what it means to rotate, like a tire rotates. And then translation's the only one that's a little bit tricky. That means to slide something from one position to another. It could be sideways, or it could be up, or it could be over and up. But that's translation. So if you remember, reflection is a mirror image, rotation is the turn, and then translation is to slide one position to another without turning or flipping the figure. Alright, so recall that two figures are congruent if they are the same shape and size. So if you look down here, both of these are congruent, but they are not the same shape. But they are the same, they're not in the same position, but they are the same shape and size. One's just kind of fallen over on its side. So we can use three types of position changes to move triangle 1 to the position of triangle 2. One change of position is to flip the triangle 1 over, as though flipping a piece of paper as shown right here. So we can flip it. Second is we can slide it over, and then the third is we can rotate it down. So let me back that up a minute. Okay, so to get this into this position here, to get this one into this position here, we can't just drop it. That doesn't work. It would look different. Okay, so we have to flip it around to get it to be like this first of all, slide it over, and then push it down onto its side so it looks like that. And that's what you're seeing here, step 1, 2, and 3. So you're doing all three transformations to get those to be the same. So let's just do some simple transformations that just require you to do a little bit of graphing. Okay, so first thing you've got to do is you got vertices R, S, and T. Y'all know what a vertex is. It's a point, and it tells you where they're located at. So let me just go ahead and do this first one for you. All right, so you do this on a piece of paper. It'd be much easier to follow and much neater. So let me just set this up really quick. So 1, 2, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. All right. So I've got 4 and 3. So come along. This is my X and this is my Y. So I come along 1, 2, 3, 4, and come up 3. 1, 2, 3. Right. Oh, right there. Okay, and then I've got 4 and 1, 1, 2, 3, 4, and 1 right there. And then I got 1 and 1 right there. So I have a triangle that looks like this, right, when I graph it. Then it says draw, and then you got your points, R, S, and T, which isn't quite as important, but it helps. Then it says draw RST and its reflection in the x-axis. So that means we're going to rotate it on the x-axis. I don't even need to draw it. I just know that if I was to rotate this like that it would look like this. Wouldn't it? Wouldn't it look like that? And then I've just got to put R would be here, S would still be there, and my T would still be over here. Let's see if we did that right. There we go. All right. So that is a reflection about the x-axis. If they'd asked us to do it about the y-axis, then we'd been over here, and it would have been like this, right? That's how it would have looked, because we would have folded it over. We would have rotated it over. All right, let's take a look at this one here. Let's kind of work on it together. If you can pause it, do it yourself. That's great. This one here, it wants us to translate something to the left and then down. So again, the first thing we've got to do, unfortunately, which is a little bit time consuming, but is we got to make our graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. All right. Now we gotta get our rectangle together. So we got 4 and 3, 1, 2, 3, 4, 1, 2, 3. So we got 1 there. We got 4 and 1, so we got 1 there. We've got 4 and 3, 4 and 1. We got 1 and 1 right there, and we've got 1 and 3, which is going to be right there. So there's our rectangle right there, and that's this rectangle right here. Now we need to take that image and we need to translate it to the left 5 and down 4. So if we take this entire rectangle and we move it over 5, so here's 1, 2, 3, 4, 5. Starting from this left edge, that means our corner is going to be over here. Now we got 1, 2, 3. It's 3 over 1, 2, 3, and up. Okay, so we've taken this and we've moved it over 5. Now we got to take this and we got to shift it down 4. So here's 1, 2, 3, 4. So we're going to be right like this. 1, 2, 3, and that's where we're going to end up. So we moved it over 5, down 4. Translated it over 5. Translation over 5, down 4. And there you go. All right. Let's see if you can do, okay, and then we talk about rotation. Let me just explain that a little bit. Rotation is that it turns like a tire. Okay, and at the beginning of this lesson, we rotate a triangle 190 degrees clockwise. So understand the biggest thing, the most important thing I can tell you here is that rotation is that it's rotate a whole thing like that is how much? How much rotation is that? That's 360. If we rotate something halfway, that's 180. Okay, so let's see if we can figure this out together. Okay, so here we got the coordinates 3, 4, and 3, 1, and 1, 1. We draw the triangle, and we want to create this image. It says, and draw its image after a counterclockwise rotation of 90 degrees. So we know we're going to be going counterclockwise, but how much is 90 degrees? Well, if you go all the way around, if that's 360, well, 360 divided by 4 is 90. So each one of these turns is 90 degrees, correct? So if we take this and we turn it just 90 degrees, right? And you rotate that. No, that one's, let me go back to this, make sure this is counterclockwise rotation 90 degrees. What's the coordinates of the vertice? So you just go 90 degrees, then you're going to have something that looks, oh, sorry about that, something that looks like that. Okay, so here we got one that's being rotated clockwise. That's being rotated clockwise. It's being rotated clockwise. So let's now let's look at some dilation. Okay, so dilation just means to dilate something is we're going to change its size, and dilation means we're going to make it bigger. If we reduce it or enlarge the figure, the resultant image is not congruent and it's not its original size. So here it's original. Here we shrink it, and here we make it bigger. Okay, so we're going to figure out how to do that, and the easiest way to do that is by doing a multiplier. For example, if we take this triangle right here and we multiply both of these by 2, we end up 0, 8. And here 0 times 0 is still 0, and here 6 times 0 times 2 would be 12. And so we've taken this here, and it is a 2 factor. This one here is 2 times bigger than this one right here. All right, so let's try to do that. Okay, so again, we've got to draw it. Get out your graph paper. It makes it easier than this. What I'm doing is really hard to keep it equally spaced. All right, so we got X, we got 1 and 1. We got one there. We got 2 and 1. We got one there. And we got 1 and 2. We got one there. Okay, so we got this little thing right here like that. And it is 1 by 1. Now it says draw X, Y, Z in the dilation image with the center of the dilation at the origin and with a scale factor of 3. So here's my origin right here, and I'm going to times it by 3. So 1 times 3 is 3. So 1, 2, 3. I can come up here, and I'm going to go sideways by 3. 1, 2, 3 go right here. So I'm going to say that that's going to look like that. Hopefully I'm right. Let's see. Yay. Okay. All right. And that's what happens. All right. So we take it and we make it bigger. In this case here was our original, and then it said that with the center of the dilation at the origin and with the scale factor of 3. All right. So you make it 3 times bigger. Okay, and so on this one here, what they did, where I took mine and I took it and I went 3 and 3 like that, a dilation of 3. What they wanted was to have us multiply by 3 and be right here, which shifted it a little bit, and so we ended up starting the I started the origin here at 0, but what they wanted was that they wanted it here at 3, 3. And so that's why theirs is up here rather than down here. But you notice that the dilation, the size increase, was still 3 and 3 because we took the 1 and we made it 3 times bigger. All right? Okay. That's it. There's course 80. And there's your TIDs. That was a little weird. Never had that happen before. Questions 11, 18, and 30. And we will see you tomorrow in class. Thank you for watching the video.